let's talk about something we all think we know, formulas. You know, those simple equations we learned back in school, the ones that seem like these absolute universal truths. Well, it turns out they're surprisingly easy to break. We're going to look at how something so simple can lead to some, well, catastrophic failures, and what it really means for how we solve problems. So let's just kick things off with a big question. Is any formula really universal? We write them down, F equals ma, volume equals length times width times height, as if they're these perfect, unbreakable laws of nature. But the truth is, the second they hit the real world, things get messy.
And this is where it all goes wrong. Units. I mean, just look at this chaos. You've got a measurement in centimeters, another in inches, maybe another in feet. All of a sudden, your beautiful, elegant formula turns into a total minefield of manual conversions. And right there, that's the moment our so-called universal truths just start to fall apart.
So that brings us to our first big idea, what I like to call the formula facade. We're going to peel back that nice, simple-looking layer and see why even the most basic equations get really complicated really fast. Okay, think about the formula for volume. Volume equals length times width times height. It's one of the first things we all learn, right? It's clean, it's simple, it feels like it should just work anywhere, anytime. But that's just the idea. That's the conceptual form. Just look at what happens when you try to actually use it. We plug in real-world numbers, centimeters, inches, meters, and bam, our clean, simple formula just explodes into this tangled mess of conversions. Oh, you want the answer in cubic inches? Well, that's another layer of math you've got to do. Every single one of these steps is a brand new opportunity to make a mistake. And we're not just talking about getting a bad grade on your homework here. These errors can have some serious consequences. So let's move on and see just how high the stakes can get when units go wrong. Let's talk about a classic trap, one of the biggest headaches in all of physics and engineering, the pound. I mean, what is it? Is it a measure of mass or is it a measure of force? The answer is, yeah, it's kind of both. And that's exactly why it's such a trap. So here's the deal. You've got pounds mass, lbm, which is how much stuff is in an object. Then you've got pounds force, lbf, which is the pull of gravity on that stuff. They are absolutely not the same thing. As you can see, to do it right, you need this extra conversion constant to get the correct answer of 10 pounds of force. But if you make the super common mistake of just mixing them up, your result is off by a factor of more than 30. Just imagine an engineer making that mistake while designing a bridge. Yikes. And if you're sitting there thinking, well, that only happens in a classroom, think again. This is not just a homework problem. These mistakes happen at the absolute highest levels, and the consequences can be, well, astronomical. Here it is, the perfect and honestly kind of painful example. Back in 1999, NASA's Mars Climate Orbiter was just lost, gone. And the cause wasn't some crazy mechanical failure. It was a simple unit mix-up. One engineering team was using metric units, another was using imperial. That tiny conversion error cost a multi-million-dollar mission. Okay, so we've established the problem, right? Formulas are fragile, and unit errors can be a complete disaster. So is there a better way? You bet there is. Let's dive into how we can completely reimagine calculation. And we'll use a tool called CalcsLive to show you how. I mean, this slide just says it all, doesn't it? On the left, you've got that tangled, error-prone mess that we're all used to. But look at the right. It's a totally different way of thinking. You just write the clean, simple formula, plug in your numbers with whatever units they happen to have, and then just tell it what unit you want for the answer. All the complicated conversion stuff happens automatically behind the scenes. Remember that volume calculation from earlier? That messy chain of math? Well, here, you just plug it all in. 200 centimeters, 60 inches, 0.25 meters. A platform that's unit-aware like this understands what all those different units mean, handles the conversions for you, and just gives you the right answer, instantly. And here's the big takeaway. The formula itself becomes tough, robust. It doesn't break just because you throw different units at it. Those equations that used to be so fragile, they finally become truly universal, just like we always felt they were supposed to be. Now, this isn't just for rocket scientists who are trying to avoid another disaster. Let's see how this brings that same power of universal calculation right into our everyday lives. I mean, how many times have you been in a situation like this? You're at the hardware store, you're trying to figure out how many bags of concrete you need for a project. The bag tells you the volume in cubic feet, but all your measurements are in inches. It's the same old problem. And what do we usually do? We kind of guess, right? Or we pull out our phone's calculator and do some rough math. But a tool that automatically understands units completely changes the game. It lets you go from just guessing to getting a reliable, fast answer that you can actually be confident in. This actually gets at something bigger, something more profound. This isn't just about having a better calculator. It's about getting back in touch with the pure elegance of the ideas themselves. I love this quote because it just nails it. The ideas of physics, the formulas, they're beautiful, they're simple. But for way too long, our tools have forced us through this clumsy, frustrating process of conversions and manual checks. This is about creating a straight line from the pure idea to the person trying to use it. And so, that brings us right back to where we started. We asked if any formula is truly universal. And the answer was, well, in practice, no. But with this idea of unit-aware calculation, the answer can finally be yes. So I'll just leave you with this to chew on. What could we build? What problems could we solve? How much faster could we innovate if the tools we used were finally as elegant as our best ideas? Hey, if you're curious about this and you want to see it in action for yourself, you can try building your own unit-aware calculations. Thanks for watching.